As we know, this will be I1, I2, I3. A very generalized approach. A very generalized approach is what I'm trying to bring. You can use complex numbers and you can solve. You can use complex numbers and you can solve. Without that also we can manage this. Each branch, how the elements are series. So what is the impedance of each branch? So can we just say that impedance Z1. These impedances, will they have, all will have same phase or different branches will have different phase? Yes, actually this is Z1, it will have a phase angle how much? I'll write it nearby. Z1 phase angle phi 1. This will be Z2 phase angle phi 2. This will be Z3. These are the phase angles. How to calculate the Z1? Z1 is quite very easy. R1 square plus XL1 minus XC1 whole square. I try to just see that simplified approach so that parallel circuit you need not to bother. No. What is Z2 impedance of second branch? Let me calculate all the things. So I got impedance, this one. Then what is I1? I1 will be VRMS by Z1. I'll get current I1. This current I1 will have some phase angle because VRMS will be there. So it will have some phase angle, that one. How to calculate that phase angle? Tan phi 1 is equal to XL1 minus XC1 by R1. Will I agree? So therefore, this is only magnitude. This is only magnitude. So what is actually the current I1? I1 should be a magnitude VRMS by Z1 and phase angle phi 1. That phi 1, I'll show it. How to calculate that phi 1? By this formula. Go back to RLC. Don't bother parallel. Take out from your mindset the parallel circuit. A series circuit is there. RLC, what is the phase angle? This is the formula. Then what is the magnitude? VRMS by Z1. I think we did. Then this I1 is having some magnitude as well as phase angle. How to calculate phase angle? This method. Similarly, the same approach. Z2 is equal to magnitude of impedance, and this is having phase angle phi 2. How to calculate that? Tan phi 2. Phase angle can be positive or negative. It all depends upon the values of L and C. So similarly, Z3 is equal to now we have some better information. So these are the current is not in phase. We'll have different phase angle. The current flowing in this branch 1 and branch 2, branch 3, they'll have different phase angles. It all depends upon the values. Maybe all will have it all depends on the values, the phase angles it will determine. How to calculate the resultant current? You can't try just I1, I2, I3. You look at this angle also, you have to take. It is as good as like you can't just add three forces F1, F2, F3. F1 bar plus F2 bar, F3 bar. Then I should go for vector sum of these currents. How the vector sum you do it? So if this phase angle is positive, this is this one. So we can resolve all that. In that one can be negative. It all if R2 some correction is there. I didn't. Second one is only having, it is not having capacitive reactance, no? Yeah, it should be like this. It is not having inductive reactance, only capacitive reactance is there. XC3 whole square. Now, can you just make a guess of this? What can be current in RC circuit? leads the voltage, no, in RL circuit, lags the voltage. I'm taking this is the reference. You have to take this is the reference. This is called like a lag circuit. This is called lead circuit, and this one lag or lead. It depends on these values XC1, XL1. I just made changes. Huh? No. So what is this I2? Should lag it, no? So the I1 I'll show it here. I1 I'm just making a guess. Let it be positive here. Then what about I2? I2 I'll bring it here. And I3 is somewhere this one. So again, how to get the resultant current? There's three vectors are there, no, you know angles, everything. So get the resultant current, and that is what I. You can solve by complex numbers. It will take easily 1 hour. At least this will take 10 minutes. Again, resolve velocity, not velocity, current. Component of current along x, along y. You'll get x component, y component. Then you'll get also the phase angle of this. And also the magnitude. Can you proceed in similar way? It's not a series circuit, it's a parallel circuit. VRMS, RC circuit. Across RC branch, current will lead the applied voltage, no? So I think what I did, I2, I3, symbols. Correct, no? This is I2. It's a parallel circuit, not series circuit. RC circuit is a lead circuit. Current leads applied voltage. RL circuit, current lags the applied voltage. I think you have to be very careful in determining that phase angles. Okay, this is a generalized approach. So now any number of series parallel, I think you can manage with this thing, that one. And do this particular resultant current will have some phase angle. How to calculate? By this method. Then what is the phase angle of circuit? This tan phi is the phase angle of circuit. Then you know IRMS. You know this IRMS. Total. You know IRMS. Then what about impedance of circuit? Impedance of circuit should be VRMS by IRMS. Now what is another alternate method? The reciprocal of impedance is called as admittance. I'll put it. Admittance, reciprocal of impedance. So the symbol will be like this. They are parallel. So 1 by Z1 plus 1 by Z2 plus 1 by Z3. This should be equal to Y1 plus Y2 plus Y3. Then another method is reciprocal of resistance is called as conductance. So the reciprocal of impedance is called as the admittance. So I think in our books they're not defined it. I'm just giving some additional information. Accidentally they may ask. So therefore when they're parallel, no, rather than calculating impedance, we'll calculate admittances will add up. If the branches, if the components are series, then we'll solve the problem taking help of impedance. When they're parallel, we take help of admittance because admittance gets added up. This is a general idea. I'll proceed to the series resonance.